Exercise 8.1. Let's continue with the question number 6. There you are asked to find the area of the region in the first quadrant enclosed by x-axis. The line x equals to root 3y that passes through origin and the circle. Now here you know that this is a circle with center at 0, 0 and the radius equals to 2. Right, r is 2 and this is line passes through the origin. So let's see roughly the required region here. So these are the two coordinate axes here. A circle with center at origin and radius equals to 2 here. You know that this is a line roughly, you can imagine, through origin and making a certain angle here like this. You can take some points and you can realize it would be this line. Okay. That's not difficult for you now why the equation of this line is represented by this. Okay, so this is your required region. This is the required region. We want the area of this region. That's the question ultimately. You know here x is 0, radius is 2, so it goes to 2. Now see here, if you consider up to this, then that's enclosed by this straight line. So we need to get this intersection point, remember. This point you need to get. This intersection point. And this region is enclosed by this circle. So we have two integrals. First, this portion enclosed by the straight line x equals to root 3y plus enclosed by this circle after this point. This region is enclosed by this curve. This region is enclosed by this, remember. Okay. So we'll get this intersection point. One intersection point you can just notice its origin. So solving the equations. X square plus y square equals to 4 and x square equals to 3y square. So I'll just place here. So what we'll get, I'll just place the value of y, remember, because I want x coordinate. So x square plus what is y square from there? X square by 3 equals to 4. So here you will get 3 plus 1, which is 4x square equals to 3 into 4 after taking LCM. So x square equals to 4 will get cancelled. So x equals to plus or minus root 3. We want in the first quadrant. So here x is positive. This is minus root 3. Remember this point. Okay. This is with, remember, center of the circle. Okay. I am not going to consider minus root 3 because in the question it is written in the first quadrant. Okay. Fine. So here this point is nothing but x equals to root 3. This is x equals to root 3. So in this portion here, limit from 0 to root 3, and then from here, let me write here x equals to root 3. Root 3 to 2, remember this portion. So here the area would be area A equals to area A equals to modulus of I, where I is given by integral from where to where? 0 to root 3 bounded by straight line. I'll write here straight line dx. Or you can write two different integrals, whichever you do, that's not important. Plus here root 3 to 2 bounded by circle here, circle dx. Remember, this is just for your information I'm writing. See, this region is bounded by this line, so I wrote here straight line. And this region, you can see, this is bounded by which curve? circle, and that is from where? Root 3 to 2. So here limits from root 3 to 2, here limits from 0 to root 3. I hope this is clear to you, remember. Fine. Okay. So now y dx, you know the formula, 0 to 3. Here y dx for the straight line. Root 3 to 2, here y dx from the circle. Now what about y from the straight line? Have a look into the equation. So here y is nothing but x by root 3. And what is y from this? Here y is nothing but the 4 minus x square. Remember, y is positive here because you are doing in first quadrant. Okay, now we just place and we integrate it. Our sum is almost over. Now this is not important for us because now this is a question of definite integral. So this is x by root 3 dx plus root 3 to 2 root of 2 square minus x square dx. Both are standard formulas. We'll just integrate this. Nothing more than that, remember. I'll keep this 1 by root 3 outside. What's integral here? X square by 2. Limits are from 0 to root 3. You know this is very well known formula. X by 2 into the same expression plus a square by 2. A square means 2 square. A square by 2, 2 square by 2, constant for sine inverse x by 2, and limits from root 3 to 2. Okay, now let's put upper limit and lower limit, so immediately we'll get the answer. So here 1 by root 3. What is this? This is 3 by 2 if I put upper limit. Lower limit is 0 plus, let me put upper limit first. If I put 2 here, this is 0. This is 4 by 2. Put here 1. So sine inverse 1. Sorry, put 2. So sine inverse 1, which is pi by 2, minus lower limit. I'm putting here root 3. So this is root 3 by 2. This is just 1. Plus, this is 4 by 2. This is sine inverse root 3 by 2. You know it is pi by 3. So just simplify this. So here you will get the root 3 by 2. What is this? This is nothing but just 4 will get cancelled. So pi, this is just pi. Let me open the bracket here. So this is root 3 by 2 with minus sign. Here, what about this? This is nothing but here 2 pi by 3. So this will get cancelled. Finally, we'll get pi minus 2 pi by 3. So this is nothing but minus pi by 3. No, it's just pi by 3, sorry. So therefore, area equals to pi by 3. This is the required area, right? This is not important. This is just definite integral. Remember, what's the important one here? Important one is this portion. How to decide the limits and how to consider the function. In this portion, straight line. In this function, in this portion, circle. Remember, 0 to root 3 and root 3 to 2. Remember. If this is not asked, if I ask the same question without this, then this portion is also there, remember. So you just need to do double of this. So in that case, you need to write here just 2. If I drop the word, which important word if I drop? The first quadrant. Everything remains same. Fine. Now, next we go to question number 7. That's also a good question. All are basic questions, remember. Let's go to question number 7 now. What's given in the 7th question? Find the area of the smaller part of the circle. Just read the question carefully. X square plus y square equals to a square. Cut by cut off by the line x equals to a by root 2. You know that this is a vertical line. Okay, so here circle, suppose it looks like this. This is a circle with center at origin and radius equals to a. Okay, so this is x equals to 0, here radius is a, so x equals to a. This is a vertical line, remember, parallel to y-axis. So suppose it looks like this. Okay, this is x equals to a line. In the exam, you should use at least foot ruler to draw the line, remember. So this is, x-axis, this is y-axis. This is which line? X equals to a by root 2. Now you can see that this line cut off this two portion. One is this, the other one is this. So this is the required region, smaller region. We want this. Now here limit starts from where? X equals to here a by root 2. So our limits are from a by root 2 to a. We want this, the entire shaded region. So what we do? We will find the area in the first quadrant and we'll just make it double. We find this. You know that this is symmetric. So this region is same as this. So I'll write required area, that is a equals to 2 times area in the first quadrant. Area in the first quadrant. Remember, area in which quadrant? First quadrant. So 2 times modulus of I. Right? This is very important. Now we write where I is integral from where to where? Lower limit is a by root 2 to a, remember, of around which axis? X-axis, so dx. So here I need to write y dx, remember. So a by root 2 to a, get y from the function. What is y from the function? That is a square minus x square. Right? You did number of times such things, so now this won't be difficult for you. Y square is a square minus x square, and therefore y is root of a square minus x square, and y is positive. Remember, y is positive because it is in the first quadrant. Fine. Now not a big task, just integrate it and write upper minus lower. Almost you are through. Okay, but still I'll be doing integration for you. X by 2 into same expression. Now you know this, we have used 2-3 times, plus a square by 2, constant first, so sine inverse x by a, remember. And limits are from where to where? A by root 2 to a. Now this is simple algebra. Just write upper limit minus lower limit. Okay, so I'll put upper limit minus lower limit and we'll simplify. If I write upper limit here, this is equals to a by 2 into 0, because a square minus a square, so this is 0, plus a square by 2 sine inverse a by a, that is sine inverse 1, which is pi by 2. This is upper limit minus lower limit. What's the lower limit? A by 2 root 2 here into what about this? Here I'm putting a by 2, so here this is a square by 2, so you will get finally a by root 2, just check please, plus a square by 2, I'm putting x equals to a by root 2, so a will get cancelled, sine inverse 1 by root 2, which is just pi by 4. I've just placed the upper limit minus lower limit. This is not a big task. Instead of x, first you put a, then instead of x you put a by root 2. Now simple algebra, let's simplify. So this is pi a square by 4 minus this is a square by 4 plus pi a square by 8. Okay, so here from this two you are just left with pi a square by here this is 8 minus a square by 4. take a square by 4 common, so this is just pi by 2 minus 1. Okay, that is I. That's I, remember, and therefore area equals to 2 times modulus of I. So 2 times a square by 4 into pi by 2 minus 1. So I'll get the a square by 2 into pi by 2 minus 1. That's required area here. 8th question. The area between x equals to y squared and x equals to 4 is divided into 2 equal parts by this line. The question is, get the value of a. This is the question. Find a. Okay. So you need to see the area. What is this? You know that this is a parabola. Symmetric about which axis? Around x-axis. Which variable is free from the square? X. So it is around x-axis through origin. So it looks like this. I told you in the very beginning of this chapter, rough diagram should be there in your mind, remember, otherwise you cannot solve such questions. This is symmetric about x-axis, remember. So it would look like this, through origin. Okay. What about x equals to 4? Here x is 0, you know origin. Suppose x equals to 4 is here. So you have such vertical line parallel to y-axis. This is a line, remember. This is the line here. Which line? X equals to 4. Okay, so this is the region. Shaded region is this much. Okay. Now area, this area is divided into 2 equal parts by the line x equals to a. So it would be somewhere here, which is also standing line. This line. So here x equals to a. Right? So area of this region is same as area of this region, remember. Okay? I repeat, area bounded by this portion is same as the area bounded by this portion. So what we do, we first find this area, then we find this and we'll compare them because these two areas are equal, remember. Now first region starts from where? 0 to, you know, this line is x equals to a. So first integral is 0 to a. And second integral is from where to where? A to pi by 4. And then we'll just compare them. There is nothing, remember. Fine? Okay. So we are given this, remember. We are given that integral 0 to a of function y dx equals to integral a to 4 of the function y dx. And see here you are including area in the lower part also, remember. So and here we are considering this much only, so you need to make it double here. Actually that's not important, it will get cancelled, but this is a way of writing, remember. So left hand side is the area of which region? That is on the left hand side of this line, this entire region, remember. What we are doing, we always find around axis and we'll make it double. Right hand side integral, this is the area of which region? This region. This region. So we find this much, and we'll make it double. Fine. Okay, now this region is bounded by which function? Look at that function. कौन सा function से bound हो रहा है? A function से. dx क्यों लिखा आपने? Because you are taking around x-axis. Limits you are clear. 0 to a and a to 4. ये कौन सा function आएगा? Parabola, this one. So from the equation of the parabola, you make the y as a subject of the expression because here formula is y dx. Y dx and x dy. If you are taking around y axis, then you need to write dy here. So now 2 you can cancel. So integral 0 to a. What is y from there? Root x. You know. Kyun positive? Because first quadrant. So a to 4, what is y here? Y is again root x. Right? You need to write here y is equal to root x and y is positive in the first quadrant. आपने फर्स्ट क्वाड्रेंट में एरिया लिखा, फिर आपने डबल कर दिया, रिमेंबर, दैट्स इंपॉर्टेंट. नाउ इंटीग्रेटेड x raised to 3/2 into 2/3 limits 0 to a. X raised to 3/2 into 2/3 limits from where to where? A to 4. 2/3 will get cancelled. Put upper limit x raised to 3/2 minus 0. 4 raised to 3/2 minus a raised to 3/2. Take this one on the left hand side. So 2 times a raised to 3/2. Square root of 4, 2 and then cube root 8. So a raised to 3/2 equals to 4. And therefore a equals to 4 raised to 2/3. So what is this? This you can write 2 raised to 2/3. And the power of the power gets multiplied. So this is 2 raised to 4/3. This is the value of a, remember. So here value of a is given by 2 raised to 4/3. You can write 4 raised to 2/3. This is also correct. Don't worry. Whether you write this or this, both are correct. Ninth question. Find the area of the region bounded by, there is a parabola symmetric around y-axis through origin, and you know that this is standard modulus function. This is modulus function, and you know that this is parabola. Both are very standard, well-known curves. You know it. You did it in 11 times, 11 standard. So I'll just draw the rough diagram here. This is x-axis here. You have y-axis. You must use foot ruler, remember, in the exam as well as even in class book also. This is y-axis. Parabola through origin symmetric around y-axis. So it would look like this, you know. Passes through origin. 0, 0 satisfy the equation. Variable y is free from the square. So parabola is symmetric around y-axis. What is this? A union of two rays at origin. Union of two rays at the origin. So it would be this. All these things you know, and you must know if you are not still clear with this. Remember what is asked in the question: area bounded by these curves, these and this. So one region is this. This is the area between two, remember. So if you recall the formula, one function minus the other function. The another region is this. ये दो region का area चाहिए. So I think now you know this is symmetric. So we just find this and we'll make it double. हम लोग first quadrant में करके double कर देंगे. ये सब आप जानते हैं. Which theory you are going to use here? Area between two functions. So we are going to use this theory. Area between two curves. Right? You know it. One function minus the other function. What is A and B? Are intersection points, remember. So I'll solve these two equations first here. ओके, वी वांट दिस पॉइंट्स. एक तो पता है आपको ओरिजिन, एक ए मिलेगा, एक ए मिलेगा. वी आर नॉट इंटरेस्टेड इन दिस, वी आर इंटरेस्टेड टू गेट दिस. तो आपको लिमिट्स मिल जाएगी. यहाँ पे तो x0 है, देखते हैं यहाँ पे क्या लिमिट होगा. देन वन फंक्शन माइनस द अदर फंक्शन. सॉल्विंग इक्वेशंस. This is the first point. We have number of such questions in the next exercise also. Whenever you are asked area between two curves, just to solve them. Okay. So here we are just solving these two equations. So y equals to x square and y equals to modulus x. So x square equals to, just comparing them, plus or minus x. So x square equals to plus or minus x equals to 0. Take x common, so x equals to plus or minus 1 equals to 0. So either x is 0 or 1 or minus 1. Minus 1 is this, remember. We want this point only, this one only. Here you have 1. Here x coordinate is 1, so x equals to 1. Right? So 0 to 1, f1x minus fx minus gx, remember. This is one function, this is the other function. Area between these two, you know that formula. So required area, that is A equals to 2 times area in the first quadrant. In subjective question portion, remember everything you need to mention the way I'm doing. You must understand how I'm writing. 2 times modulus of I here, remember. Okay, area in the first quadrant. Where what about the I is integral from where to where? 0 to 1 fx minus gx. One function minus the other function. इसमें order important नहीं है. Now fx means what? Y. एक function में से y निकालो minus दूसरा function में से y निकालो and just integrate it. So I'm doing here only. You can continue with the next line. So therefore I equals to integral 0 to 1. First function में से y क्या होगा? What's y from the first function? X square. Have a look here. Y from the first function. Minus here gx means again y क्योंकि x का एक्सप्रेशन चाहिए dx है ना. सो यहाँ पे y मॉड्यूलस x होगा बट आपको मॉड्यूलस x लिखने की जरूरत नहीं है, x ही लिखना है. क्यों? हैव यू रियलाइज? फर्स्ट क्वाड्रेंट, सो इट्स पॉजिटिव. ओके, आपने यहाँ पे x ग्रेटर देन 0 कॉन्सेप्ट यूज़ कर लिया, रिमेंबर. दैट्स वाई एवरी टाइम वी आर एम्फसाइजिंग ऑन द फर्स्ट क्वाड्रेंट. बस ना हो गया, इंटीग्रेशन कर दो आप. एक्स क्यूब बाई 3 माइनस एक्स स्क्वायर बाई 2. Limits 0 to 1. Upper limit रखो. Simplify this. What you will get here? 2 and 3. So let's simplify this. 1 by 3 minus 1 by 2. Lower limit दोनों 0 हो जाएगी. So this is nothing but the minus 1 by 6. This is not important, minus sign, क्योंकि आपने मॉड्यूलस रखा है यहाँ पे, right? And therefore finally area equals to 2 times modulus of minus 1 by 6. So we'll get 1 by 3. This is the required area of that region. Remember, ये दोनों include हो गए. A भी हो गया, A भी हो गया. क्यों fx minus gx क्या? वो मैंने already theory में explain कर दिया आप लोग ने. खाली आप fx लिखेंगे तो ये पूरा region cover हो जाएगा, पूरा. Just to remind you, ये पूरा cover हो जाएगा. Only fx, it is always with x-axis, remember. gx लिखेंगे तो इतना ही कवर होगा क्योंकि ये gx से बाउंड हो रहा है. फिर ये दोनों का सब्ट्रैक्शन कर लिया तो आपको जो येलो रीजन है वो मिल जाएगा. आई होप दिस इज क्लियर टू यू. वेरी स्टैंडर्ड क्वेश्चन, रिमेंबर. एरिया बिटवीन टू कर्व्स. गेट द इंटरसेक्शन पॉइंट, राइट द सिंपल फॉर्मूला fx minus gx and integrate it. You are through. Next question, question number 10. Again the copy of previous question. Find the area bounded by the curve x squared equals to 4y. You know it's a parabola. This is parabola. Symmetric about which axis? Around y axis, because here y variable is free from the square. Around y axis, remember. Passes through region. And you know that this is just a straight line. That we know, right? This doesn't pass through region. Okay, so let's see the rough diagram here. You can do some questions without drawing diagram also, but I'll just show you here. Okay, this is the x-axis. Here we have y-axis. This is y-axis. Then parabola, the symmetric about y-axis, passes through origin. So it would look like this here. This is nothing but x squared equals to 4y. Parabola, symmetric about y-axis. How do we draw this line? Very simple. Take x equals to 0, for example. What is y? If I put 0, y would be 1 by 2. X is 0, then y is 1 by 2, somewhere here. Okay, you can take y equals to 0. If I put y equals to 0, what is x? Minus 2. So minus 2 comma 0, somewhere here. So the line would be like this roughly, remember. It would look like this. This is just diagram of line. Now which region? This region. This is the region between these two curves. We want the area of this region. Okay? Area starts from where? Here. So this is your one limit. Area starts from here. So this is your one limit. Where the area ends over here, this is your another limit. And how do we do this? Fx minus gx, that's the formula. Now how do we get this x and this x. Just we solve these two equations, parabola and straight line. So you write solving given equations. Solving given equations. We are just solving the equations. Why we are solving these two? Just to get the limits. Okay. So what I'll do, I'll find y from these and I'll place here because I want x, remember. So therefore x square equals to, I can find 4y. What's 4y from there? X plus 2. Understood what I did? Just we have eliminated y. y को हटा दिया क्योंकि y नहीं चाहिए, हम लोग को तो x में इंटरेस्ट है because हम लोग around x axis कर रहे हैं, remember. So what I did, just I got y and I placed the 4y and I placed there. Factorize this. X square minus x minus 2 equals to 0. What are the factors? You know, minus 2 and plus 1. So x is minus 1 and y is 2. So these are your limits, minus 1 and 2. Fine. This is the most important part here. So area, that is A equals to, inside the modulus you have I, where I is given by integral from where to where, starts from minus 1, it ends at 2, one function minus the other function. दोनों में से आप क्या y फाइंड करेंगे? y फाइंड करेंगे. फॉर्मूला क्या होता है? y dx, remember. So get the y from both the functions and place here. मैं just करके देता हूँ आप लोग को. What is y from the first function? Integral minus 1 to 2. What is y from the first function? X square by 4. Have a look at it formula. What is y from this? X square by 4. Minus, what is y from there? X plus 2 by 4. Right? Now you just integrate it. 4 you can take it outside. Simple quadratic function. Integrated right upper minus lower. So आपको finally area मिल जाएगा. I hope this you can do. This is very basic question of definite integral. How I got x square by 4? From here. Y subject of the expression. Here gx. So y should be subject of the expression. X plus 2 by 4. That's required integral here. And finally you will get the area after integrating. Do upper minus lower. Question number 11, that's the same question. Area by this parabola and this line. Okay. Now, you know that this parabola is symmetric about which axis? Around x-axis, because x variable is free from origin. Free from square, I'm sorry. And it passes through origin. So it would look like this. This is x-axis. Here this is y-axis. Okay. Parabola would be around x-axis, so it would be like this, through origin, remember. This is y square equals to 8x. X equals to 3, suppose 3 is here. You know here x is 0, here x is 3. Then this is just a vertical line. This is simply a vertical line, x equals to 3. So which is required duration? The required duration is this. This is the required duration. This one as well as this one. So you must have noticed now, after doing at least 10 questions, we get this area and we'll make it double. This bounded by this parabola, starting from 0, ending at 3, remember. We just get area of this region and we'll make it double. Okay, that you know now. We find the area of this region. This is same as this, and we'll just do double. Bounded by which curve here? Parabola. So here, required area, let me write, that is A equals to 2 times area in first quadrant. Area in first quadrant. Okay, so 2 times modulus of I. Fine. Now, where I is given by from where to where? I is from 0 to 3. Remember, A portion का आप find कर रहे हैं. 0 to 3 with dx, so here y axis. Okay, here y variable. This is this portion only, remember. When you represent this integral, it always gives the area with one side of the axis, remember. Integral से पूरा area नहीं मिलता है. Around x axis, so you wrote dx, y dx, remember. Now, get y from the function. What's y from the function? Here y will be, 2 root 2 into root x. Right. Y would be, what is y? That would be 2 root 2 root x. I'm sorry, here there is a mistake in question. It should be 4x, 4x, yes. This should be 4x. Okay, so here it would be just y equals to, what we'll get from this? Y equals to just 2 root x, and y is positive. Y is positive because it is in the first quadrant. Okay, please correct this. This should be 4x, not 8x. Okay, so you'll get the 2 root x dx. Now integrate it, 2 as it is. What's the integral of this? That would be x raised to 3 by 2 into 2 by 3, limits from 0 to 3. So this is 4 by 3 here. Put upper limit first. So it would be root 3 raised to 3 minus 0. So we will get here 4 by 3 into 3 root 3. Root 3 3 times. This will get cancelled. So this is just 4 root 3. This is I, remember. And therefore area A equals to 4 into 2, that is 8 root 3. But here you must have realized that this place, when you put upper limit, this means, here I wrote it directly, this means 3 raised to 3 by 2. So take the root first. So root 3 the whole cube. That's what I wrote directly this. I hope this must be clear to you. Right. And this means root 3 times. That's 3 root 3. So finally this is the area. Okay. Next question. Area of this circle in the first quadrant, lying in the first quadrant, between x equals to 0 and x equals to 2. Draw the rough diagram. Immediately you will realize, without doing integration even you can answer it. There is a circle with center at origin and radius is 2. You know this. Right. You know here x equals to 0. This is x equals to 2. Right. You want area from where to where? 0 to 2, between these two lines. Where? In the area lying in the first quadrant. That is, you need this much only. You need this. So here this is MCQ. You can write directly answer. What's the area of the circle? You know, pi r square. What is r here? R is 2. So this is 4 pi. Now total area is 4 pi. You need just in one quadrant. So 4 pi by 4. So you'll get the pi. And that is nothing but your option A. Right? This is MCQ. So you can think like this. How will do by integration? If it is asked in, subjective. So the here area, that is equals to modulus of I, where I is given by from where to where? 0 to 2, bounded by the circle. Circle means what? You get y from there, y dx. Y dx. Get y from this, that is 4 minus x square. Y dx. Okay, integrate it. X by 2, same expression, plus a square by 2. A square by 2, sine inverse x by a, sine inverse x by 2. Limits from where to where? 0 to 2. Let's put the upper limit first. If I put upper limit, here 2, but here 4 minus 4, 0. This is 2 into sine inverse 1. This is nothing but pi by 2. minus 0, this is also 0. So you can see that you are getting I equals to pi, therefore area equals to pi, right? But in MCQs you can think like this as I explained here. But the diagram should be there in your mind. What is asked in the question, that should be in your mind. Okay. Next question. Question number 13. Area of the region bounded by y square equals to 4x. This is a parabola. Remember, this is the first instance. There you are given find around y-axis and the line y equals to 3. Remember, probably this is the first such question. There the area is around y-axis. Now what is this? Let me draw the diagram. The first one is nothing but the parabola, symmetric about which axis? Symmetric about parabola, symmetric about which axis? Which variable is free from square, that is variable x. So it's nothing but around which axis? X-axis, passing through origin. So parabola would look like this. Okay, so it's from here, and y equals to 3 is a horizontal line, remember. So this is y equals to 3. Earlier probably in all examples you did around x-axis. Here you are doing around y-axis, horizontal line, remember. Y equals to 3. Here what's the value of y? Y is 0 here. So this is the area. Ab question padho, you will realize. This is the required region. You want the area of this region. I'm reading the question. Area of the region bounded by this parabola, y square equals to 4x, which is symmetric around x-axis, passes through origin because 0, 0 satisfy this, around y-axis, and the line y equals to 3. Y equals to 3 is horizontal line, remember. Okay, so you want this area. Area starts from 0, it ends over here. So area equals to modulus of I, where I is given by integral from where to where? 0 to 3 around y-axis. So I'll write dy, area around y-axis player, I remember. So here I should put x dy and y dx, you know, x dy and y dx. Now what we do, we make the x as a subject of the expression, remember, okay, in the function. So what is x from the function? A parabola है आपके पास, remember, this is a parabola, y square equals to 4x. You need x from this. What is x? Y square by 4. So integral 0 to 3 y square by 4 dy. So 1 by 4 will go out here. What's the integral of this one? Y cube by 3, and limits are from 0 to 3. So 1 by 4, this is just upper limit. So 3 raised to 3, that's 27 by 3, and lower limit is just 0. So you will get here finally 9 by 4, that's I, and therefore area equals to again 9 by 4, which is your option B. In this entire exercise, probably this is the first question. There you did area around which axis? Y-axis. Okay. Now you can go ahead for the next exercise. I'm sure you can do it. Try. I'll send, of course, the complete solution. But this is the only concept. Just concentrate at the required region and try to get the limits.